So this is for section 8.4 for Calc 2, and it's on trigonometric substitutions. So the first thing when you're looking at these integrals is you want to see if there's a u substitution or if there's anything else that you can actually do to solve them. If nothing else works, that's when you're going to go to the trig substitutions. So you're starting with something that's algebraic, and you're going to convert it to something that's trigonometric, integrate it, and then back substitute. There are three things that we're looking at to see if we can do a trig substitution. One is if I have a radical somewhere, it doesn't matter if it's in the numerator or denominator, and I have the square root of a squared minus u squared. If it's in this form, I'm going to let u equal to a sine theta. If I have somewhere square root of a squared plus u squared, and again this one can be switched because they're just added together, I'm going to let u equal a tangent theta. And if I have a radical that says u squared minus a squared, so now my variable squared is first, and then minus the constant squared, I'm going to let u equals a secant theta. And then I'm going to build out these triangles. So I'm going to work through a few different examples so that you can see exactly what I am talking about. So these are not the same ones that are in your handout because there are solutions in there. So I wanted to do some different problems. So I have the integral 1 over x squared times the square root of 25 minus x squared. So I'm focusing on that square root of 25 minus x squared. So this is the form a squared, because I have a constant, minus u squared. So my a is going to equal 5, and my u is going to equal x. So to set it up, it's u equals a sine theta. So in my case, u is equal to x, so I get x is equal to 5 times the sine of theta. Now I want to go back over here and see what else I'm going to need. So there's an x squared there, so I'm going to square it over here. So x squared is equal to 25 sine squared theta. And I'm going to need to do a substitution for dx. So if u is equal to x, take the derivative of both sides, I get du is equal to dx. And I want to take the derivative of 5 sine theta. So when I take that derivative, dx, it's going to equal derivative of 5 sine theta, which is 5 cosine theta. So I have everything over here that I'm going to need. And I like to draw my triangle because it helps me to keep everything straight. And then sometimes you have to go back to the triangle to do your final back substitution. So theta is going to be, we started off with x is equal to 5 sine theta. So if you just solve this, x over 5 is going to equal sine of theta. And we know sine is opposite over hypotenuse. So this last sign, and you can use the Pythagorean theorem if you want, but that's where we're going to get that square root of 25 minus x squared. So I have all that put together, and now I'm going to go back to my original integral and start substituting in. So the integral for that dx, I'm going to plug in 5 cosine theta d theta. For that x squared on the bottom, it's 25 sine squared theta. And then for the square root of 25 minus x squared, I want to substitute in for that as well. So if I look at my drawing here, square root of 25 minus x squared, I can substitute in for that for 5 cosine theta. Alright, so just looking at it, square root of 25 minus x squared, we get 5 cosine theta. Or you can, again, cosine is the adjacent over the hypotenuse. So when you solve that, that's where you get the 5 cosine theta. Alright, so I have everything, and I can simplify. So this 5 cosine theta and that 5 cosine theta just simplify out. I'm going to bring that 25 out front. So I get 1 over 25. And then we're left with 1 over sine squared, which is cosecant squared theta d theta. The integral of that is cotangent, a negative cotangent. So I end up with negative 1 over 25 cotangent theta plus c. Now that I've integrated, I have to go back to my original, because when we started off, we didn't have any cotangents or sines or cosines. There was no trig. It was algebraic. So we have to go back and substitute in. So I have negative 1 over 25. So cotangent, looking back at my triangle, we know tangent is opposite over adjacent. So cotangent is adjacent over opposite. So I get square root of 25 minus x squared over x, and then plus c. And you can pull that 25 down the bottom if you'd like. Alright, so let's try another one. We have x cubed over the square root of 1 plus x squared dx. Alright, so I have a squared plus u squared. So if it's an addition in there, then it has to be the tangent. So u equals a tangent of theta. So my u is going to equal x, and my a is going to equal 1.